Okay, so last couple questions here. A cube has a surface area of 300. Well, that has to be split up between 6 equal surfaces. Okay, so then I'm just going to draw a net of my cube. If each surface is equivalent, then I'm going to divide by 6, and I can say that each square is 50. So the side length then, is taking that square area and square rooting it. So it's going to be square root 50. Okay. Again, I prefer that you use the exact value. This is about 7.1 or 7.07. To calculate the volume, I'm just going to use the exact side length, square root 50, and I'm going to cube that number. Okay, so taking square root 50 and cubing it, I get 300 approximate. This is approximately. The decimal value is approximately 353.55 centimeters cubed. Okay, so this surface area gives us this particular volume. Okay, so last thing is talking about surface area to volume ratio and explain their effects. So there's two things that affect the surface area to volume ratio. Okay, so the size. A larger object of the same shape has less surface area. This is why cells inside, your cells in your body can't be super huge. Okay, because if they're really big, they have a lot of volume, but they have very little surface area which to transport nutrients through. Okay, through osmosis and through the cell membrane. So size. Okay, a larger object of the same shape has less surface area. Okay, it has less surface area to volume ratio. Okay. The other thing is shape. Okay, so shape is the other factor involved. So the two things are size and shape. If you have long, flat objects, okay, you have more surface area. There is more surface area to volume ratio. Okay, so if you flatten out something really flat, you have very little volume, but you have lots of surface. So you have a large surface area to volume ratio. Okay, so when you want to maximize your surface area to volume ratio, you have kind of long, flat things. The object that minimizes your surface area to volume ratio, to have the shape that has the least surface area to volume ratio, is a sphere. That's the least flat object that you can get. So the smallest, okay, so I'm just going to say the least surface area to volume ratio is from a sphere shape. Okay, so if you watch some of the videos in number 14, the lesson 14, there are some videos there that reflect why people in the northern hemisphere, they tend to be kind of shorter and rounder, whereas people, because they need to conserve heat, so they want very little surface area to give off heat, so they want to be more spherical, whereas people near the equator, okay, they want to kind of give off heat, so they want more surface area, so they tend to be taller and skinnier. So an example of H is size, right? We could talk about cells. You should give your own examples, but things like cell size, okay, we want to have small size for more surface area to volume ratio. Okay, shape, okay, we can talk about, long, flat things. We can talk about that idea of different shapes give us different surface areas. So if I want to conserve heat, and have very little surface area, I'll kind of curl up in a ball. If I'm really hot and I want to give off heat, I want lots of surface area, so I kind of lay flat and lay flat out so that I have more surface area. So wide and flat, lots of surface area. Small and bundled, like in a sphere, you have small surface area.